to reduce power and yeah, save some money. And I'll mention just briefly as well, something else you should be looking at is whether you have a lot of variable speed drives on site. So that's something that can kind of influence whether implementing a power factor correction can sometimes play havoc with variable speed drives if you have them, have a lot of them on site just by the way they operate. So that's something to consider there. It's not a necessarily a deal breaker for them, but something yet to factor into your considerations. Okay, so looking in a bit more detail at your demand-based tariffs. So this is looking at your electricity bill and your contract. So there's a few of you out there who are responsible for paying the bills. You may have a bit of understanding around this, but for the others, I'll just run through this at a relatively high level, and then if there's more questions, we can come back to it. But typically, there's two main types of tariffs. You either have a bundled or unbundled tariff. So the bundled ones are more common in residential or small commercial, and that's where you just pay a fixed rate. So you might be paying, for example, 25 cents a kilowatt hour for all your power or your energy, and that's all you really see. That's, you kind of negotiate that, and that's you pay that rate for the given volume of energy. What I imagine a lot of our audience is on is what's referred to as an unbundled tariff, and that's where the costs are broken down into different components. So you'll have a retailer component, a network component, an environmental, and a market component. And so the retailer component is really just looking at the energy you're buying, so the volume of charge. The network is looking at the distribution and transmission side of things. So while the retailer really kind of covers off on the cost to generate the electricity and the retailer cost, the network is the poles and wires. So that's the infrastructure to get the electricity to your site. The environmental charges are the government-imposed environmental charges, so things like the renewable energy targets, energy efficiency schemes, things like that. And the market components is typically much smaller percent of your bill, and that's really just to administrate the scheme. So that's to make sure everything's distributed, kind of scheduled and organised. So basically runs the market. And so what we're looking at really then is one of those network charges, is the demand charge. So if you've got a bill handy, it could be worth bringing out just so we can look as we go. But the demand charge you'll probably find is one of the largest components. And as you'll no doubt notice, the electricity bills have risen pretty dramatically over the last 5 or so years, and it's largely due to increase in these network charges. So the demand charge, what it's effectively doing is you get charged on the maximum amount of power your site draws. There's a few different ways this is charged, but effectively what this is doing is it kind of works on a cost for making sure, what it's really doing is making sure there's enough capacity in the system for, typically on those hot summer days when demand is highest, to make sure everyone can get the power they require. So if you've got a really high demand, your charge is going to be larger than a site with a lower demand, typically. And usually like a fixed an annual rate, so you get charged a certain amount per KVA or per kilowatt per year, and then that's times by the actual amount or the figure for your demand. And depending on where you are and the size of your site, there's a few different ways that these can be charged, and this will influence whether the cost effectiveness of implementing power factor at your site. So some places will have a rolling 12-month maximum, so the highest value you have for your demand, that will set the charge for the following 12 months. And then once that 12 months is expired, it'll ratchet down to the next highest value, which will then roll on for the next 12 months. So anything you do on site to reduce that demand, you're probably not going to see changes for another year, but then hopefully it will drop until that next high demand value And while we're at it, that's probably something just to look at and see what your demand is and when that occurred, because sometimes those charges don't get passed on, or the value doesn't drop down. So it might be some quick wins for you there to have a quick look at that value and see where there's savings there. One of the more common ones is just a monthly maximum demand, so that's each month of the year, whatever the maximum figure is for demand for that month, that month is what will be charged for that month. And then another common structure is to have a summer or week peak demand period. So this might be typically it's a couple of hours on hot days. So your distributor will give you a heads up as to when that is, and then your demand during that period will set it for the rest of the year. So kind of irrelevant what you're doing the rest of the year, it just really matters in those few hours. And that's going to set the charge, which can be, there can be big savings there, and just changing how you're operating on those few days if that's an option for you. And then, power factor and other energy efficiency things can help to reduce that further. So the kind of the take home from all this is to whether power factor correction is suitable for your business. What you need to be having is an unbundled tariff, so you need to be able to see your demand charge there, and it needs to be based on the KVA rather than kilowatts. So some sites might just charge your demand on your active power, which so it doesn't really matter what the power factor on your site is. Okay, so I've just got an example here of an unbundled tariff in case you're an unbundled tariff, just so you're familiar with what I'm talking about. So you can see there those first two line items there are the energy charge, so that's the retail and generation charge, and then just getting charged a peak and an off-peak rate for the quantity or the volume of energy in those periods. Then there's the market charges, the metering charges, the environmental charges, and then the network charges down the bottom, and that's what we're looking at there. And it's actually those last two items we're looking at, the demand capacity, and this site here, this example one, has a critical peak demand variable. So they've got a fixed charge there, that demand capacity, that second last line for 500 KVA. So that's based on their transformer capacity, and then the variable for them is that critical peak demand. So they have a few days in summer and a few hours on those days that sets that demand next year. And you can see that's all the total network charges there, 6,300, and the two demand charges are about 3,800. Of the total bill, you can see that's a large, it's pretty much the same as their energy, so it's over half of their bill is on the demand. So big incentive there for these guys to reduce that. So once we're happy we're on a KVA charge, that's the one in particular, the two main requirements. The second is what the power factor is at your site. And it's probably not something that's obvious. Sometimes your invoice will actually say when what your KVA was and what the kilowatts was at the maximum demand. So you can just do a simple calculation, divide the kilowatts by the KVA, and that'll give you an indication of the power factor you've been charged at. But if you want to do a more detailed analysis, particularly if you have a monthly demand charge, or you're curious and want to get a better handle on it, you can request interval data from your retailer, so that'll give you you can see there in that example, the kilowatts and the KVA for each half-hour interval throughout the year, which is useful information in itself. Gives you an idea of your demand profile for your site. You can have a look and see whether there's any really big irregularities. And you can also get average power factor and power factor those maximum demand events. So yeah, through the retailers is one avenue. You also may have power monitoring systems on site, depending on the complexity of your system. You may be able to just extract that out of there and use similar format. And yeah, you can then have a look at that just through Excel or some similar program. The take home from that is that the lower the power factor, which again is the ratio of the real to the apparent power, and then the more beneficial power factor correction is likely to be for you. Okay, and so just got an example here, just from a typical site, and this is quite a common trend here. So we're looking at we've got a relatively low base load there of around about 50 kilowatts, and then through the day we're seeing that black line there lift up as production increases through the day, and then drops back up at the end of the day, back to that baseline there. So we're seeing the green line there as a power factor. So on that right-hand side, seeing they've got a power factor of just under 0.8, which is pretty common for a lot of sites. And then the blue line is the KVA. So that's what we're going to get charged on there, is that maximum value there around about 130 where it peaks. You can see there it's because of that low power factor, it's considerably higher than the kilowatts. And so then if we would have put in power factor correction, lift it up to kind of sizing it to improve the power factor up to around about 1. So you can see here we've corrected the power factor. So for the bulk of the day, when the load's lower, the power factor is around about 1. And just through those production hours in the middle of the day when the load lifts, we have power factor dropping down a little bit, but still around about 0.95-ish, I think is the lowest it gets down to, at that when we've got that maximum demand. And then the two dotted lines there, so that's the power factor is lifted. Our load stays the same, so that's the kilowatts, the black line, so that hasn't really changed. But what we've done is, by improving that power factor, we've improved the KVA, and that's, you can see there it's much tighter, it's much closer to the actual active load, active power, and so it's dropped what would be charged on dramatically. So with the installation, so once we're happy that it's something we want to look into further, there's another number of companies out there that will install the units, and you can kind of work out what's suitable for your site. Typically, you want to install the power factor correction as close to the large loads as you can, but often it's just done at a site. You just do it once at a central substation or the feedings of the site, because that's where you want to try to balance that out. So it avoids having your capacitor bank there, so it avoids having your power supply company sending that reactive power down to you. You just generate it there at your meter box at the substation, so to avoid them doing it. Depending on how complicated your site is, you might have them spread out close to the large loads, or even potentially built into the power consuming equipment. Obviously, yeah, the more complicated it gets, the higher the costs go. But there are benefits to your site power quality by spreading it out.